the veteran system. Here we go. All right, so when we're looking at simplifying radicals, one of the ways you may have seen this done is break 18 up into the square root of 9 times the square root of 2. So one number that you can take the square root of, and the other number you can't. So then the square root of 9 becomes 3 times the square root of 2, and there's your answer. So when we're dealing with smaller numbers like these, the 18, the 24, it's depending on how well you know your perfect squares and how well you know all the factors to the number, that may be easy to do. However, if you don't, or just trying to go through all the factors, that's where we can look at the prime factorization. So the square root of 18, the first prime number I can divide 18 by is 2. Then that leaves me with 9. Since I can't divide 9 by 2, I go to the next prime number I can divide that by, which would be 3. And I have 3. So I show the prime factorization like that. Factor trees work as well. So any of that you do to break that out is fine. We're dealing with square roots. So the index of all these radicals are going to be 2. That means I look for groups of 2 on my numbers. So I have a group of 3s, which means that comes out. Anything left not grouped, which would be the 2, is left under the radical. So part of the reason I like the prime factorization is you don't have to worry about knowing the factors of the number and then knowing which factors of the number are perfect squares. You just start dividing it by the prime numbers and then look for groups. So if we look at this with 24, I can divide that by 2, which leaves me with 12. I can still divide that by 2, bless you, which leaves me with 6. And I still can divide that by 2, which leaves me with 3. So again, looking for groups of 2 numbers. I have a group of 2s. Bless you. I do not have any more numbers I can group together. So whatever is left, 2 times 3 under the radical. So 2 root 6 is my final answer on simplifying. Now, the other thing I need to mention, the Casio calculators that simplify the radical themselves, because they do. I believe there's one Texas Instrument that does as well. But if you have a TI-30, you're fine. Keep in mind, if you have one of the Casio calculators, I'm not going to prevent you from using it now. But when it comes to assessments, you will not be allowed to use that Casio calculator because it simplifies them for you. So as we're going through the notes, going through the homework, definitely recommend using that to check your work. Okay? But as far as what you'll be allowed, I will trade you out the Casio with one of mine that does not simplify them for you. Okay. All right. So if we look at 160, I can start by dividing that one by 2, leaving me with 80. And I just keep going with that number until I can't use it anymore. So 2. And we can keep dividing that by 2 till we get down to 10. And we have 1, 2, 3, 4, 5 2s and a 5. So every group of 2 numbers, I'm going to circle up. So this time I have 2 groups of 2. Underneath the radical, I still have what I was not able to group, which is a 2 times a 5. So 4 root 10 as my final number. Square root of 17. Can I break that number up at all? No, 17 is a prime number, so there's nothing else that can be done. We leave it as it is. So see what you can do with those 6 after that. All right, so when we're looking at the next groups, doing when you can simplify and when you can't. So when we have 20, divide that by 2, leaves us with 10. Divide that by 2, leaves us with 5. So we have a pair of 2s followed by the square root of 5. 24 we've already got on the front. So that would be 2 root 6. We've already done that one. 40. Divide that by 2, then we're down to the 20. Still, we only have a pair of 2s. Underneath, we have 2 times 5 left. So that's 2 root 10. Whatever is paired comes out from under the radical. Whatever is left stays under it because it didn't have a pair to bring it out. Square root of 10. There's nothing there. It's the square root of 10. It's 2 times 5. There's no pairs of numbers at all. So when we look at 50, divide that by 2. We have 25, which I can break that down as 5 times 5. So when you're breaking these down, it doesn't mean you have to start with the first prime number. You could start with any prime number that you can divide these by. So I could have started with 5. It's just my habit is start with the lowest and work my way up to keep all the numbers together. So I have a pair of 5s and 2 left under the radical. So number 6 with 300, divide that by 2. We have 150. I can keep dividing that by 2. Gives me 75. When I divide that by 3, I have 25. And there's a pair of 5s there. So as I'm circling the pairs, I have 2 times 5 with a 3 left. So making sure you don't circle things so much that you lose track of the one that isn't in the group. So that would be 10 root 3. Okay, so the next part, if there's something already outside the radical, that still isn't going to change how we simplify the radical. Okay? So we're still going to break down 125. I can divide that by 5. And I can keep breaking down with the 5s. So I have a pair of 5s times the 6 that's already out with a 5 left under. So that's what usually gets forgotten when we simplify the radicals, forgetting to multiply it by something that was already out there. So this is 30 root 5. You will see that a lot, especially as we work on that last section with the fractions, and not forgetting to multiply that out. So if we break down 18, which we have on the front page, it's a 2 and the 2 3s. So I have a pair of 3s times the 2 that's already out there with a 2 left under the radical. So that's going to make it 6 square root of 2. So number 8, we have the 12. Two 2s and a 3. So I have a pair of 2s times the negative 4 that's already out there, and a 3 left under the radical. So negative 8 square root of 3. So work out the problems in the next row. So if we break down 72, we end up with 3 2s and 2 3s. So I have the 6 times the group of 2, the group of 3, and a 2 left under the radical. So 6 times 2 times 3 is 36 root 2. We've broken down before. So it should be a pair of 2s with the 5. So 1/2 times the group of 2 and 5 left under the radical. 1/2 times 2 leaves us with just the square root of 5. So that's 1 times the square root of 5. It doesn't need to be a 1 in front. Number 11 should have broken down as 5 2s. So we can just keep dividing this by 2 until we get to the end. I have 2 groups of 2. So that'll be negative 10 times the 2 groups of 2 and 1 2 left under the radical. So negative 40 root 2, or square root of 2. Okay, so that's something you're going to see as we work through these. Again, this part of the unit, the part 2, is really setting up how we need to write our answers and work with them in part 3. Radicals in the denominator. We can't leave them there. So we have to do what's called rationalize the denominator, making sure that we do whatever we can to get rid of it. So if the square root of 2 is in the denominator, I need 1 more to make a pair of it. So multiply the top numerator and denominator, just like you would change any fraction, by the same thing. So up here, I have 6 times the square root of 2. Below, square root of 2 times the square root of 2 becomes the square root of 4. And what is the square root of 4? 2. So now I have 6 root 2 over 2. No more radical in the denominator. But these two numbers outside the radical, 6 over 2 becomes 3. So 3 root 2. So your first job, get rid of the radical in the denominator. Once that's done, what can you do to simplify what's left? So the second example here. What would we do? That'll work. So the 6 and the 3 are both under a radical, so that becomes 2 square root of 18. The 2 3's I'm multiplying under the radical becomes the square root of 9. The square root of 9 is 3. Okay, so now I can't do anything to simplify 2 over 9, but I can simplify the square root of 18. Oh yeah, it should be 2 over 3. I get so used to working with these, and I forget to what I'm saying versus what I'm writing. So the square root of 18, we can break down. We've got that several times on here, so that's a 2. And the group of 3's. So that's 2 times 3 root 2 over 3. What's going to happen now? Two times 3 is 6. 6 over 3 becomes 2. So several things you have going on to simplify it at the end. Okay. So let's take a look at the next row there. Number 12. I have 1 7, I need another. So across, that means I have 3 square root of 7 over the square root of 49 now. Square root of 49 is 7. Can I do anything to simplify 3 over 7? Nope. So that is my final answer. What about 13? What am I going to multiply by there? Yep. So multiply top and bottom by a square root of 3. So under the radical here, I've got 8 times 3, so that's now the square root of 24. Under the radical here, I have square root of 9. So square root of 24 over the square root of 9, which is 3. And I need to simplify the square root of 24. So simplify that and see what you can do with 14. So square root of 24, when we break that down, divide that by 2. Again, keep going. You wouldn't necessarily need to show that again because you've already got the square root of 24 broken down somewhere in your papers. So that becomes 2. Under the radical, we're going to have 2 times 3, which is 6 over 3. Can we do anything to simplify 2 over 3? So no. Again, I'm not doing anything with the square root of 6 and 3 because the square root of 6 is, we can't do anything with it until we took the square root of 6, which that gives us a decimal. So you can only simplify like numbers. So integer to integer, radical to radical. So 14. Multiply both of these by the square root of 7. So that becomes 7 times the square root of 7. 8 times the square root of 49 now. So the square root of 49 is 7. And you're going to multiply that by, so now we'll have 8 times 7 in the denominator. We'll have 7 over 56, which leaves us with 1 over 8. So the square root of 7 over 8 as a final answer. Again, we can drop these 7s here because they are outside the radical. So it works with things that we can factor out. All right, see what you can do with those on the back. So on this one, if you just take the problem as it is, we would multiply top and bottom by the square root of 15. So then we have the square root of 315 over the square root of 225. So that is the square root of 315 over 15. So breaking out 315, can divide that by 3 or 5 to start with. So I have a pair of 3s. So that is 3 square root of 35 over 15. So I can simplify 3 over 15 as 1 over 5, which is square root of 35 over 5. So here's the key. I divided both the 3 and the 15 by 3 to simplify it to 1 over 5. Could I have simplified the 21 and 15 by 3 at the beginning? Yes. Because they are both under the radical. So those kind of things to watch out for as we're working with that. The square root of 7 times the square root of 3, the square root of 5 times the square root of 3. So I can take, since both of them have the square root of 3 in them, I can take that out. Which then just leaves me with the square root of 7 over the square root of 5, which will get me to this answer as well. So be looking for ways. If it's helpful, it doesn't have to. It will simplify to the same answer. But it also keeps you from working with some of those bigger numbers to have to simplify at the end. So number 16, multiply both by the square root of 3. So I have 5. Then under the radical, I'm going to have 2 times 3, which is 6. Here I'm going to have 9 from the 3 times 3. The square root of 9 is 3. So 5 root 6 over 3. There's nothing I can do to simplify 5 over 3. So that would be my final answer. So looking at 17, I do have the 3 in front, but I have the square root of 30 over the square root of 6. Is 6 a factor of 30? Yes. So I'm going to look at it like this. I have a square root of 6 over a square root of 6. Can I just factor that out? It's gone. And there's your factor. So part of working with these kind of numbers is reading what they are. Especially when we deal with fractions like this. There's a lot more things that you can read and work with and simplify as you're doing the problems. All right, so 18 is another one. I can multiply top and bottom by the square root of 20. However, 15 is the square root of 5 times the square root of 3. 5 and the square root of 20 could also be broken up using the square root of 5. There's other ways to break up 20, but that's the way that means I can do some work with this. So I have square root of 5 over square root of 5. Again, multiplication, so I can divide anything out that's common. So I'm left with square root of 3 over 5 times the square root of 4. And what's the square root of 4? So the square root of 3 over 5 times 2. So square root of 3 over 10. So I actually didn't need to multiply by anything to get that radical to go away in the denominator. So it's just looking at what I can do. All right, so this next one. Well, I can't do anything with the square root of 8, but the square root of 100 is 10. All right, problem solved. No more radical in the denominator. So now we just need to simplify square root of 8. So if we're looking at 8, divide that by 2. So I have a group of 2's with the 2 left under the radical over 10. So I've got this 2 over 10, which is 1 over 5. All right, so looking at number 20, I have the square root of 6 over the square root of 27. Do 6 and 27 share any common factors? What? 3. So that would be the square root of 2 times the square root of 3. And that'll be the square root of 9 times the square root of 3. So I can divide both of those by 3. And I'm left with the square root of 2 over the square root of 9, which is 3. So square root of 2 over 3. Using your number sense, what you know about numbers, instead of just following a process every single time because, well, we multiply both sides, top and bottom, by the square root of 27, which will work. It's just going to leave you with some bigger numbers to factor and work with at the end. Okay? So that last row is nothing that we can simplify ahead of time. So I'm going to be multiplying top and bottom here by the square root of 5 on 22, numerator, denominator by the square root of 3, and the last one, the square root of 5 again. So that should be the work on those last ones. Now, looking at these last few, so that would be 4 times the square root of 5 over the square root of 25. So 4 root 5 over 5. Nothing I can do to simplify 4/5. So that's the final answer there. 22, 3 times the square root of 3 over 5 times the square root of 9. So 3 root 3 over 5 times 3. So we've got 3 over 15. So then we're left with the square root of 3 over 5. Multiplying here, the square root of 15 over 2 times the square root of 25. The square root of 15 over 2 times 5. The biggest mistake, again, is not correctly reading the pieces of the problem. We have the square root of 15 over 10, not 15 over 10. So 2 different kinds of numbers. We cannot break that down any further.